So let's talk about how traffic actually gets to your application. So let's assume that your agency's website or application is available at example.gov. And you've got end users out there that you want to be able to access example.gov, obviously. So your users sitting down at their computer, firing up their web browser on their laptop. My apologies, I only know how to draw laptops from 1996. The first thing that's going to happen is their laptop is going to do a DNS lookup. And that DNS lookup is going to resolve the address for example.gov. Now your agency has its own DNS entry. Your agency is actually given a CNAME record or a canonical name record that we provide to you that allows this domain to actually be resolved. This is part of bringing your own domain to Cloud.gov. But this flow actually would be exactly the same whether you were using your own domain or you were using our default app domain, app.cloud.gov. So the exact same thing would happen for example.app.cloud.gov as an example. So that DNS lookup is going to resolve the name, and that name then is going to point to an ALB, or Application Load Balancer. Now this is a load balancing component. You may have heard Amazon, the previous versions of these were called elastic load balancers. But this is actually a piece of infrastructure from Amazon that we configure and that we set up. So this is a load balancer, and it's load balancing across our Cloud Foundry routers. And so from here on out, everything is inside of Cloud Foundry. I'll just draw two routers for now, but we run multiple instances of these routers. And so this load balancer is sitting in front of all of the different routers that we are actually running as part of our Cloud Foundry infrastructure. Okay, so the ALB is essentially going to route that request to one of the routers. It doesn't really matter which one. Now, you actually have multiple instances of your application running in Cloud Foundry. And your application is containerized, and so your application is running alongside of a lot of other applications, and those are all running on specialized virtual machines that are set up to run essentially lots and lots of containers. But let's say that you actually have 3 instances of your app, and I'll just shade those in. So those are on, let's say, these 3 components here. Now, just like the application load balancer is load balancing across the routers are actually load balancing across your application instances. So your request will get routed to one of the particular routers. It will do a lookup in its route table to say where are the application instances for example.gov, and it'll pick one. It basically does round-robin load balancing. And so it'll pick one, and it'll say, okay, here you go. I'm going to send you over here. And you get sent over here to this virtual machine that's actually running all those containers. It's actually called a cell. And that cell will get the request, and that cell will actually forward the request onto your particular application instance. Now, inside this virtual machine, all it's doing is using network address translation, or NAT, to actually get requests routed to that particular instance. Everything inside this blue space over here is on a private network, a private subnet, inside of a virtual private cloud running in Amazon. And so that's how all of your traffic actually gets from your application over to your application instances. Now, I actually drew this picture this way because we actually are running, I'd said, in a virtual private cloud for Amazon, but we're also actually running across 2 availability zones. And so I'll just label that AZ1 and AZ2. Now, an availability zone in Amazon terms is essentially sets of physically isolated hardware. And so the idea is if one of those availability zones from an Amazon perspective actually fails, the other one doesn't fail. And when we deploy Cloud Foundry, when we deploy all of these different components, we make sure that instances of each of those components actually land in different availability zones. So we actually have multiple routers running in each availability zone. And when you, as a user of Cloud.gov, deploy multiple instances of your application, not only do we try to make sure that your application lands on different cells, that's these VMs running in the containers, but we also make sure that your applications land in different availability zones. And what that means is that if one of these availability zones fails, the other one is still running. And so from an end user perspective, the interruption is non-existent.